Cindy took out 2 student loans to pay her $30,000 tuition bill. She took out a government loan with a 3.5% interest rate, and she covered the rest with a private loan that had a 6% interest rate. What was the value of each loan if the total amount of interest after 1 year was $1,425? In this case, they're asking us what was the value of each loan, so we're going to let those values be x and y. The first loan was a government loan, so let's let the value of the government, and I'll abbreviate that, the government loan be x, and then the other was a private loan, so let's let the value of the private loan be y. Now, just like the other problems, we need to set up a table so that we can organize our information. In all of these interest problems, the relationship is going to be principal times rate equals interest. And we're always going to label the columns like that because that will help us organize the information we have and figure out expressions that represent the information that we don't have. Now, there were 2 types of loans, the government loan and the private loan. So the first row I'm going to label government and the second private. And then we'll start in the upper left-hand corner. The upper left-hand cell represents the principal for the government loan. Now, in the last problems, the principal was the original amount invested, but in this case, it's the amount borrowed, or the value of the loan. So in this case, that's going to be x, because we said that the value of the government loan was x. And then the private loan has a value of y, or a principal of y. So we're going to put that down below. The interest rate for the government loan was 3.5%. As a decimal, that's 0.035. For the private loan, it was 6%, but more expensive, so that's going to be 0.06. And again, we're going to multiply across the principal times the rate to get the interest. So in the first column, that's going to be 0.035x. And in the second row, that's going to be 0.06y. Now we're going to need 2 equations that model the situation. So we look back into the problem to see what information we haven't used. It says that the total tuition bill for Cindy was $30,000, and since she covered that with the 2 loans, we know that that's the total value of the loans combined. That's the principal. It's the original amount that she borrowed. So we're going to put that at the bottom of the principal column because it's the total principal. And then the total interest we can see is $1,425, so we're going to put that at the bottom of the interest column. And we're going to get our 2 equations from the principal column and the interest column. In the principal column, the relationship is x plus y equals 30,000. And then in the interest column, we're going to have 0.035x plus 0.06y equals 1,425. And just like the last one, we're going to solve this via substitution. You can isolate either variable in the first equation pretty easily, and you can use that for the substitution, and either one will work. But I always do the one that has a smaller coefficient in the other equation. So if we look in the other equation, the coefficient on the x is smaller. 0.035 is smaller than 0.06. So I'm going to isolate x in the first equation. To do that, I have to subtract y from both sides, and that gives me x equals 30,000 minus y. Now I'm in a position to make the substitution. Because x is equal to 30,000 minus y, wherever I see an x in the other equation, I'm going to substitute 30,000 minus y in that equation. So the second equation is going to become 0.035 times 30,000 minus y, that's the substitution, plus the 0.06y, and the total is 1425. That's what I get after I make the substitution. Now I have to distribute that 0.035. 0.035 times 30,000 is 1,050. So I have 1,050 minus 0.035y plus 0.06y equals 1,425. Next, I'll combine like terms on the left-hand side. Negative 0.035y plus 0.06y is equal to 0.025y. So I have 0.025y plus 1,050 equals 1,425. At this point, I can subtract 1,050 from both sides, leaving me with 0.025y on the left and 375 on the right. And when I divide both sides by 0.025, I end up with y equals 15,000. Since y was the value of the private loan, we know that the value of the private loan is $15,000. We still have to find the value of the government loan. But if Cindy had $30,000 in total of loans and $15,000 was from the private loan, we can subtract to see that the rest, the government loan, had to also be $15,000. If you can't see that right away, you can always go back to substitution. We knew that x was 30,000 minus y, and then we figured out that y was 15,000. So we've got 30,000 minus 15,000, and that equals 15,000. So the value of x is also 15,000, and now we're ready to state our conclusion. We were asked what was the value of each loan, so we can write the value of the government loan is $15,000, and the value of the private loan, in this case, is also $15,000. And that's our final answer.